Caroline Chen. I'm with Intel. I'm Vice President at our Network Platform Group and manage the 5G Infrastructure Division. We're focusing on building out the 5G infrastructure with the best state-of-the-art silicon and the appropriate accelerators and the foundational software to enable our customers that who typically provide equipment in the telecommunication industry to fulfill the race to build out a 5G network. Yeah, 5G, unlike the previous generation of wireless, actually actively defined three distinct use cases. In the previous generation, people typically talk about either voice or data. Now we're actually talking about enhanced mobile broadband, which you can interpret as a huge pie for data, and obviously voice is part of that, given the voice over IP. And then the other two very interesting definition is you also need to serve what they call a mission critical communication. So things that require very low latency, maybe a huge burst of data, but you need to process that in a timely fashion. Think e-health being one thing, cloud robotics control being another one. And then the third category is like massively connected, like smart city. These three actually, from the layman's term, sounds like, oh, well, why don't you do all three? In reality, from a wireless technology point of view, those three has very distinct and orthogonal requirements. Mm-hmm. So a 5G actually defines and meet all these from the get-go. So that's a huge difference between them and the previous generation. Why does that mean to the edge? That means by incorporating all three of these use cases into the foundation of 5G definition, that means you serve a different orthogonal enterprises requirements, and you push the smart all the way to the edge. Before, you don't do anything, you take all the data, all the analytics information to the data center, you process, you send it out. But because of all the latency requirements and because of the massive connected internets of things, it doesn't make sense both in terms of technical viability, commercial viability, and cost to process everything on a data center. So you have the tiered edge. So you have data in the middle, they have the near edge, and something called a far edge. That means it's very much close to where the users are, the things are, the enterprises are. So that's why 5G and the edge are really connected. It's very much linked. One enables the other. 5G enables the edge to become commercially viable and technically feasible, and the edge makes a 5G use cases comes alive. This is my first time in a DCD. I didn't know what to expect. When I sat in the second panel, you have, I knew I was in trouble when there's a professor of applied psychology being a moderator. I'm like, oh no, what are we gonna get? But Drew did a phenomenal job in outlining, laying out what the future can look like. And the surprising thing is that the panelists actually came from very diverse background. So I obviously came from extremely wireless-centric background, you know, and everybody else came from, some of the people came from very data center, you know, seen it, been there, I've seen it all. And I've tried to remind people is that the fundamental difference between what data center was before and what data center could be in the future, enabled by 5G, because data center in the past is always, it's about abundance. That you need as much as compute you want in a data center, because I think someone mentioned that you already optimize it so much. You really squeeze every efficiency out of it. But now you change the game. You say, well, the data center maybe need to go out to the edge, and now you have the cost, started coming up, resiliency, and all of those things come up. But you got to remember, what I was said before, is that 5G is wireless traditionally market to scarcity, but now 5G really for the first time opened up the opportunity to say you could have a whole lot of bandwidth available to you. How do we utilize the bandwidth to push the data center, proliferate it to the edge for certain amount of data? Like I mentioned at the end, the two types of data I think that requires it. One is data that requires mobility, think connected car. One is the data with expiration date, things that like transportation, typically meaning that like when a plane lands in a domestic airport in the US, they only have about 45 minutes to unload their data. Afterwards, it's no good because the plane will take off and the data gets overwritten. So there is a certain amount of expiration date. You got to process it right away, get analytic information. For example, if there's something wrong, potentially wrong with the plane in terms of mechanical, need to know right now and not 20 minutes later, 10 minutes later. You want to do that right away. Facial recognition for security reasons is another one. So anything with the data with expiration date, you need to process that. I think those two could be one of the main drivers to push the edge. So I'll try to bring that out. Hopefully I was successful to show people that data center has a time and place at the edge with the advent of 5G. And I really enjoyed it, and this is my first time at DCD. I really think this DCD is really relevant as we're marching towards 5G, and I hope to be able to participate in the future as well. Everybody talk about Moore's Law, but there's a Shannon's Law.
Okay. Yeah, and Moore's Law says you can go on getting more, and Shannon's Law says
there's a limit. There's a signal to noise ratio. There's a limit. I think we're pushing very, very close to the limit right now. That's why everybody is looking for different ways to extend the life of Shannon's Law by using bigger bandwidth, looking at different type of spectrum. And between Moore's Law and Shannon's Law is a very interesting intersection. I think data center on the edge really plays a vital part in that game.